I've found that the more I delve into the wondrous mysteries of the cosmos, the more I find myself steeped in a profound sense of confusion and even deep doubt. Our collective understanding of the universe, the very story we tell ourselves about its origin, may not be as certain as we once believed. Perhaps, just perhaps, the universe never truly came into being at all. What we have always called the Big Bang, that singular moment of creation, may not have been a beginning, but merely a transient stop, a single point in an endless cosmic cycle. And if this were true, it would mean that the very foundation of cosmology, the bedrock of our physical laws that we've spent decades studying and building upon, could crumble in an instant. This feeling, this deep sense of intellectual loss, is akin to suddenly realizing that the ground beneath your feet has been suspended in a vast, empty void all along. And yet, I am compelled to face these new discoveries, these startling observations that keep pouring in from the edge of the known universe. For example, we see the subtle temperature variations in the cosmic microwave background, and the most distant, ancient starlight captured by the James Webb Space Telescope. They all serve as a constant, haunting reminder that the seemingly complete story laid out in our textbooks is, in fact, riddled with contradictions and loopholes. And so, in the time we have together, I want to take you on a journey into this almost unsolvable enigma, to face the one question that has troubled humanity for millennia: what truly existed before the Big Bang? Let's start with a simple question. What would it look like if we could truly witness the very childhood of our universe? You might imagine it as a canvas of absolute darkness. After all, in those earliest moments, there were no stars, no galaxies, not even light could travel very far. But, in a strange and beautiful twist of fate, the universe left us a baby picture of itself, a haunting image hidden in every corner of the sky. This light is so faint, so delicate, that it's almost undetectable to our senses. But with the right instruments and a profound sense of curiosity, we can find it. Scientists have given it a name: the cosmic microwave background, or CMB. It is the first light that the universe was able to leave behind after the Big Bang, making it our sole window into that formative epoch. This light was born roughly 380,000 years after the Big Bang. But why did it take so long? Because before that moment, the universe was an unimaginably hot and dense place. It was a chaotic cosmic soup. A photon of light, no sooner was it created, would be scattered by a free-floating electron. It simply couldn't travel. The entire cosmos was enveloped in a rolling, impenetrable fog. It was not until the universe finally cooled down enough for electrons to combine with atomic nuclei, forming the first true atoms, that the change could happen. In that singular moment, those photons were finally liberated from their confinement. The cosmic fog lifted, and a single, breathtaking flash of light filled all of space. Today, we can still receive this light. But after 13.8 billion years of cosmic expansion, it has been stretched and redshifted into the form of a faint microwave signal, so weak it's invisible to our eyes. And yet, this light is our most reliable evidence for the early universe. It doesn't just record the light of that time, but a blueprint of the universe as it was first forming. But this baby picture is far from a perfect, uniform image. On the contrary, it is filled with tiny, almost imperceptible temperature spots. And don't underestimate them. Their temperature difference is only 100,000th of a degree, but it is precisely because of these small irregularities that the future of the cosmos had a story to tell. Where it was slightly denser, Gravity would later cause it to collapse into a galaxy. Where it was slightly sparser, it would eventually become a cosmic void. In other words, the magnificent galaxies and star clusters we see today, all of them are inscribed within that ancient photograph. The CMB is not just light. It is a profound blueprint that determined the very course of the universe. And yet, what is even more bizarre is that the temperatures in some places are strangely anomalous, such as the so-called cold spots. This has forced scientists to wonder, are these signals truly from the Big Bang, or are they relics from a previous universe? But before the mystery of the cold spots could be solved, the universe was already brewing a new change. The first generation of stars, population 3 stars, were about to light up the darkness. These were monstrously large stars, 100 times bigger than our Sun, with incredibly short lives. Their fusion created the heavy elements necessary for life. Without them, there would be no galaxies, no planets. There would be no us. They ended their lives in spectacular supernova explosions, scattering those life-giving elements across the cosmos. This was a moment of true cosmic creation. But the question is, how could we possibly see these stars that have been extinguished for billions of years? The answer is the James Webb Space Telescope. It was launched to specifically capture that faint infrared light from the earliest parts of the universe. And when its first results came back, the entire scientific community was shocked. In just a few years, Webb had photographed galaxies that were both earlier and brighter than we ever expected. One galaxy, named MUM-Z14, broke all records. Its light came from just 280 million years after the Big Bang. This means the universe had already nurtured a massive galaxy when it was less than 2% of its current age. And what's more, these galaxies aren't isolated. They exist in staggering numbers. This has forced scientists to re-examine our models of galaxy formation. The structures we thought took tens of billions of years to form, why were they completed in a mere few 100 million? Could our entire cosmic script have been flawed from the very beginning? The logical assumption is that the journey from primordial matter to a massive galaxy should take an immense amount of time. But Webb's images tell us that galaxies appeared in a fraction of that time, and their brightness defies all our theoretical predictions. This has led many to believe that our model for how galaxies formed is simply incomplete. If that is the case, it means the very cosmic timeline we have constructed over decades may need to be entirely rewritten. But the problem is, we still can't find a reasonable explanation for why. And so, some have suggested that the answer lies not within the galaxies themselves, but on a much larger scale. According to the foundational principles of cosmology, the universe should be uniform on a sufficiently large scale. It has no bias. It should look the same everywhere. This is known as the cosmological principle. The theory dictates that large-scale structures shouldn't exceed a certain size, or they would break this uniformity. The universe should be like a smooth, even surface with no major bulges. But when scientists actually mapped the universe, what they found challenged this limit yet again. Just as we thought we had defined the cosmic boundaries, an observation in 2024 completely shattered them. Scientists discovered a massive ring-like structure they called the Big Ring. Why was this so shocking? Because the Big Ring has a diameter of 1.3 billion light-years and a circumference of nearly 4 billion light-years. To put that in perspective, the local supercluster where our own Milky Way resides is only about 500 million light-years across. The Big Ring is dozens of times larger than our galactic home. This alone would be a startling exception. But the universe threw out an even bigger problem, near the Big Ring. Scientists also discovered another colossal structure they called the Giant Arc, spanning over 3.3 billion light. This discovery completely smashes the concept of a theoretical limit. And so, the question is no longer whether there are exceptions, but why there are so many of them. One anomaly could be a coincidence, but dozens of structures defying our core principles. This makes us question whether the cosmological principle we've always believed in was wrong from the very beginning. And so, we must turn our attention to the deepest mysteries that make up the universe: dark energy and dark matter. We used to think that the universe's expansion would slow down due to gravity, which acts like an invisible hand, pulling everything together. But an observation of a supernova in 1998 completely overturned this idea. Scientists found that the universe wasn't slowing down, it was accelerating, as if an unknown force was pressing the accelerator. This mysterious force was named dark energy. It doesn't emit light or heat, but acts as an invisible anti-gravity, pushing the universe to expand faster and faster. Its discovery was the first time we realized we were not in control of our own cosmos. According to measurements, dark energy makes up almost 68% of the total universe. Everything we are familiar with, stars, galaxies, and even ourselves, plot. All the visible matter makes up less than 5%. The world we live in is just the tip of a cosmic iceberg, and if you add the mysterious dark matter, which is about 27%, the reality we know is simply a thin layer of decoration on an invisible cosmic net. This leads us to the profound philosophical question: is the reality we rely on truly just a background character? And are the true architects of our existence the forces we have never truly understood? We have always thought of dark matter as a gravitational glue holding galaxies together, but we have never been able to directly detect it. We can only see its gravitational effects. Some scientists describe the search for dark matter as chasing a ghost. We can feel its presence, but it never shows itself. And so, faced with this continuous failure, some have wondered if we are looking in the wrong direction. Maybe dark matter doesn't exist at all, and what we need to change is our very understanding of gravity. So, the fundamental question remains: are we truly studying physics? Or are we trying to trace the lingering relics of a previous universe? Our long-held theory of the Big Bang has explained so much, but when we add dark energy and dark matter to the equations, it starts to fall apart. Perhaps the universe was never a one-time event, but has experienced more than one explosion. The Big Bang we know might just be one of countless flashes in a grander cycle, but we have no evidence to prove it, nor the courage to completely deny it. And so, after a century of pursuit, we still have not reached the end. This leaves us with the deepest of questions. Is time truly a continuous river, or is it a mere illusion of our own perception? Does time have a beginning and an end? And if so, what happens to existence when it stops? If all of this is destined to vanish, what is the meaning of our existence? The ultimate question is not whether time will end, but when the river of time is bound to reach its end. With what courage and what posture will we choose to complete this long and mysterious journey? When I look back on this long exploration, I realize that what has been bothering me has always been that initial question. Because the more I study the wonders of the cosmos, the more I feel that maybe it never truly came into being. And after all these complex theories and discoveries, we have not found an answer, but a deeper mystery. Asterisk, asterisk, asterisk. If this journey through the mysteries of the cosmos has sparked your curiosity and left you with more questions than answers, please give this video a thumbs up. Your support helps us continue to explore these incredible topics. Don't forget to hit the subscribe button and the notification bell so you don't miss our next adventure. Thanks for watching, and we'll see you in the next video.